Determine the current through the battery in the circuit. First case, immediately after the key is closed. So immediately after the key is closed, the capacitors are not charged yet. So the current flows through all the branches. So the current flows through here, the current flows through this branch. So immediately since capacitors are not charged, they don't have any voltage to oppose the flow of current also. So then R2 and R3 are considered to be connected in parallel. So the effective resistance, parallel resistance of R2 and R3 is this R2 R3 upon R2 plus R3. Okay, so this is the parallel connection of resistors, and they both are in series with R1. So the net resistance of the circuit immediately, that is in the case 1, is R1 plus R2 R3 divided by R2 plus R3. That is taking the LCM, R1 R2 plus R1 R3 plus R2 R3 by R2 plus R3. So this is the net resistance. Therefore the net current flowing immediately would be voltage divided by this net resistance. So voltage divided by R1 R2 plus R1 R3 plus R2 R3 by R2 plus R3. Okay, this is the current in case 1. Now the case 2 says in a long time interval. So by long time interval, they mean the time interval enough that these capacitors are charged. Now once these capacitors are charged, the current through these branches would not be flowing. That means there will be no current through this C1 branch, no current through the C2 branch. So the currents will only flow from this branch. So current will, after a long time, the current will flow like this only. So in that case, in case 2, the net resistance would only be that of R3 and R1. And since the same current will flow through both of them, the net resistance would be the series resistance. So the current in case 2 would be voltage by the net resistance. So after a long time, this is going to be the current. Okay.